When it comes to probability theory, sample spaces are a fundamental concept because they help us identify the possible outcomes we can have in some experiment. Now, an experiment is just some situation we're interested in, and as an example, we can have a coin flipped 2 times. That's an experiment. And now we have heads or tails at each flip, and those would be outcomes of the individual flips. But over 2 flips, what would be the possible outcomes? Well, we can identify this using our sample space. If we do this 2 times, or in other words, if we flip our coin 2 times, we have the following possible outcomes. We have heads, 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 tails, tails, heads, or tails, tails. Right? These are all the ways we can observe the coins being flipped. And this enumeration of all the possible outcomes is simply called omega, or in other words, the sample space. The sample space is denoted omega. Now, when it comes to elements of the sample space, we denote them with this small omega, and that's just some notation for things that are contained within the sample space, the elements of a sample space. That's what this small omega represents. So this is a fundamental concept, as I mentioned, in probability, because we can define subsets of a sample space as particular experiments, as we'll learn later on, and we can calculate probabilities and do some interesting stuff. So stay tuned, and thanks for watching.